All right, so anatomy of a Java class. We kind of looked at this a little bit the other day. It says we learned to use classes and objects that are built into Java. Yes, we did. Strings are a class that are built into Java. The scanner class as well. We've used those before. In this unit, we're going to learn to write our own classes and make our own objects. So we actually did a little bit of that on Friday with the ball class. If you remember, we made that ball class. There was not a ball class before. We created it ourselves. So, creating a class, remember that a class in programming defines a new abstract data type. Okay, so when you create objects, you create new variables or instance of that class data type. Wrong thing, here we go. So, a class, I like to say a class is a definition. I like to say a class is a definition of a type. For example, the string class is actually something that somebody has programmed, has written themselves. Or a team of programmers over at Oracle and Sun Microsystems have actually defined the string class. When you define a class, you have to do many different things, but essentially you're saying what data comes along with your class. So for example, the ball class we made, we said the data was like the X's, the Y's, the color. We did that, and also the diameter. And then you also define the behavior. What can the class do? And if you remember from Friday, our bubble class, I believe we made it so our bubble class could ascend, and we could also display our bubbles. So when we say a class is a definition of a type, you're just basically saying what does everything that's an example of your class have in common. That's why I say it's like a template. We talked a little bit about a student class. What do all students have in common? They have a name, a student ID, a grade, a GPA, stuff like that. That would be the data for that class. There's also the methods. What can the student class do? You could see if a student qualifies for the honor roll. You could even see if they're gold honor roll. What is it for Celine? There's gold honor roll, silver honor roll. That's it? No bronze? What about like a participation honor roll? All right, never mind. But that would be an example of something that the class can do. You can figure that out based on the data. So a class is a definition of a type. I like to say it's like a template as well. You're saying everything that's an example of this class has this stuff in common. Every string you make, you can call the substring method on. You can call the length method on. They all have that kind of behavior in common. That's what you're thinking about. When you create a class, you describe there's a couple different ways we can put this. One way I'm going to put this is you describe the nouns and verbs of a type. That's one way I'm going to put this. So for the ball class, the nouns, the stuff was like the X's, the Y's, the diameter, the color, the stuff. Essentially, for a student class, the nouns would be like the name, the ID, the GPA, the grade level, stuff like that. Another way to put this that maybe makes a little bit more sense, instead of nouns, you might think of it as the data. So the data that's associated with a ball is an X, a Y, a diameter, a color. And instead of verbs, you might think of it as the abilities, or basically what the class can do. So, for example, for the string class, the nouns would be like the strings, the characters inside of a strings. The abilities would be length, substring, index of, any string method, 2 uppercase, 2 lowercase. Those would be the verbs or abilities of the type there. So it's just 2 different ways to kind of think about it. Some people like the nouns and verbs kind of analogy. Some people like the data and abilities there. What do you guys, is that sound? Do you guys hear that sound? Okay. A class is like a cookie cutter. There is one cookie cutter and many possible cookies. So, for example, the ball class. We made a single ball class. Do you remember how many ball objects we made a single bubble class on Friday. How many bubble objects did we get on the screen? You're like 100 at one point, right? Some of you might have changed it to 1,000 or more. But I only needed to define the class once. One cookie cutter, one class definition, many possible different opportunities to use that class. So I like to say it's like a cookie cutter. If you've ever made cookies at home, you essentially have a lot of cookies that look the same. Maybe they're all snowmen, but you can decorate them in different ways. So they look similar, but they have some stuff that's different about them. We watched this little video on Friday with Mad PhD. I honestly cannot watch it again. It got a little bit too zany for me. I've got a pretty high zane level that I can take. This got a little bit too zany with the happy house stuff. But if you want to go back over it, you're more than welcome to. Maybe skip the last culturally insensitive part where they were having the Russian people make the house at the end. I assume they were Russian. I feel like that's what they were trying to get through there, but I'm going to skip that video for right now. Let's see here. Okay, so we've talked about classes. What is a class? It's a definition of a type. So there's like a string class, a scanner class. We get to make our own classes. We get to define our own types now. And when I say type, what am I talking about? Well, there's several types we deal with. We deal with like int, double, string. Those are all types. Now we get to make our own types. Is kind of what's interesting, what's fun about that. Okay. So now that we've talked about what a class is, like the ball class that we looked at on Friday, what is an object? They have a very tight relationship with each other. If a class is the definition, an object is just an instance of a class. Objects are just instances of a class. So on Friday, we made the ball class. Ball was the name of the class. No, why am I lying? It was Bubble. Liar. Bubble class. Super Bowl, man. Got me. Bubble. This was the name of our class on Friday. And then from that class, we made many different bubble objects. We made many different bubble objects. I think there was one named B. You could make a bubble object named B1, bubble object B2, B3, B4, stuff like that. If it were the string class, string would be the name of the class. You could have str1 that contains hello. You could have one that contains greeting or something like that. You could have a lot of different strings. One class definition, many different possible objects. So if classes are like cookie cutters, objects are the individual cookies. And what I mean by that is when you make cookies with a cookie cutter and then decorate them, they all kind of look similar. All the snowmen have 3 pieces to them, or if you're making some other holiday cookie, they all kind of have some stuff in common, but you might decorate them a little bit differently. And those differences are individual cookies. Those are like the objects. They're all kind of similar, but they have their own individual differences, just like you're all students. But you're all a little bit different. You're not just numbers, right? You're all special snowflakes. You're all a little bit different, but you have a lot of stuff in common: a student ID, a name, a GPA, grade level, etc. Java is an object-oriented language, which means that Java programmers think about objects and the interactions between them. Think about this. If you're writing, I saw a couple of you playing a game earlier on the computer, or maybe you played a board game or a card game over the weekend. You have to think about how objects are going to interact with each other. If you've ever played, anybody ever played Pokemon or know what Pokemon is? Okay, a couple of you. Okay, so let's say Pokemon is a class. You can have different individual Pokemon, like you got Bulbasaur, you got your Charmander, you got your, what's the one garbage Pokemon? He's literally garbage. What's his name? Garbodor, thank you. You might have one of those, so those are all individual instances of a Pokemon class, but then they have to interact. They have to be able to battle with one another. They have to be able to take damage or give damage, stuff like that. So they interact with each other. If you've ever played like a Mario video game, or you ever watched somebody play Mario, I'm trying not to use all video games. They're just really good examples. In Mario, you've got, Mario, the character, and he interacts with the Koopas and the Goombas, and he jumps on them and stuff like that, and they interact with each other. Or if you ever played chess, here's an example. Chess piece could be a class. Everybody knows chess, right? So chess piece could be a class, and then you've got like a king, you got a knight, you got a queen. They are all similar, but they're different. They can all move, but they move in different ways, and they need to interact with each other. That would be an example of objects, those pieces. They're all a little bit different, but they have a lot of similarities between them. Okay. Let's see here. How do I feel about going back to this? I don't think we're ready to go back to this just yet. Objects versus classes. An object is an instance of a class. Sometimes I like to say they're a specific example of a class as well. If student is the class, you yourself are an instance of that class. You yourself are a student object. You're a student object. You're a student object. You're a student object. The characteristics and capabilities of the object are defined by the class that was used to create that object. How did our processing code on Friday know how a ball was supposed to work? Because we wrote it, and you guys were giving me suggestions. Have the ball go back to the bottom of the screen. Have the ball change colors. Have the ball go left and right. Start randomly on the screen somewhere. The only way that processing knew how to make a ball behave was because we ourselves wrote the ball class. Why do I keep saying ball? Bubble. The bubble class. It's going to be a long day, everybody. It's going to be a long day. Whoever's listening to this video at home is going to have a very bad time. I'm sorry. I'm sorry. If you're listening at home, I'm sorry. Okay. Here's some ASMR for you. Okay. All right. So, okay. So using everything I've said so far, filling in the blanks here. Dog is like a class, while my dog Bella is like an object. You guys are so smart. My dog Bella is 18 years old, not in dog years, in human years. There, yes, like the Methuselah of dogs. She can't see anymore. She can't hear anymore, but gosh darn it. She a good dog. She is like, she's kind of a mutt. She's like half Jack Russell, half Papillon, half something else. I don't know. She just won't die. And my dad says he wants to have her taxidermied. Isn't that crazy? Sorry, I'm not supposed to use the word. Isn't that wacky to do that? That's totally whack. Say what?
Taxidermy is like the thing that everyone had their job thing when they put their like animals.
Oh, the ACT work keys thing? Yeah, it's like, what job do you want? Oh, you could be a birdhouse builder. Okay, I don't know if that's really a job.
I wouldn't do that and like get taxidermy.
Yeah, I don't know if you like do you think you'd be a better taxidermist if you liked animals or hated animals? Probably. I don't know. All right. I'll build a bear. Then you probably hate bears or children. Or both. Okay. All right. Okay. Excuse me. Okay. So down below, in this example here, it says to write your own class, you typically start a class with a class declaration. Another way you could put it is called a class header that says public, then class, and then the name of your class. We've been doing this since like day, 3. Public, class, whatever. But we haven't really actually defined classes correctly. We've just kind of used them as containers for our main methods. We're actually going to start using classes the correct way very soon. But here's an example related to the video we watched on Friday. Public class house. The house class is going to have all the data, all the variables that's associated with the house. It's also going to have all the methods. What can a house do? And then down below you see some different house objects created. My house is created. Neighbor's house is created. This syntax should look, when I say syntax, the way this is written down here, this should look very, very similar. What does this look like to you? What variables have we created that look kind of like that? Yeah, doesn't it look like scanner KB equals new scanner system.in? It kind of looks similar to that. I see name of the class, name of the class. Name of the object, name of the object. Keyword new, name of the class again, name of the class again. And then the only difference is this stuff here in the parentheses. These are called parameters. It's kind of like when we call one of the math methods, when we say math.square root, math.pal, math.abs, something like that. It's just extra data that you need to make an object. This is actually how you create an object, is what you're seeing down here. So in this case, house is the name of the class. My house and neighbor's house would be names of objects. And the idea is, just like we did with the bubble class on Friday, you can make one class definition like house, but then make many, many different house objects. We made one bubble class, many bubble objects. Reading along, it says, remember that objects have attributes and behaviors. These correspond to instance variables and methods in the class definition. Okay. Going back to our notes here. Up above, I want you to add one more thing. When it says when you create a class, you describe the nouns / data. The other word I want you to put in here is / instance variables. It's just another word for nouns or data or instance variables. It's kind of a weird combination of words, but the data for a class is called an instance variable, and the reason it's called that is you're saying every instance of this class has this data. Every instance of a student class is going to have a name. You have a name, you have a name, you have a name, you have a name, you have a name. Every instance of a student class is going to have a GPA. So you all have GPAs. Every instance of a student class is going to have a grade level. So that's why we call them instance variables. Every instance of the class is going to have that data, but it might be different values for the data. Down here where it says verbs and abilities, the other word for that is methods. The way that we describe what a class can do is by writing our own methods. We're not going to necessarily get to talk too much about methods today, but the methods are just what a class can do. The methods that we wrote for the bubble class on Friday were ascend and display. We were able to make a bubble ascend. We were able to make a bubble display on the screen as well. Okay. Moving along here. Moving right along. It says instance variables hold the data for objects, whereas the methods code the behaviors or the actions the object can do. That's why I call them the verbs sometimes. A class also has constructors, we'll talk about that on its own day, which initialize the instance variables when the object is created. If you remember the bubble class from Friday, we had a special little piece of code that made the x value a certain random number. We made the y value a certain random number. We randomized the color, stuff like that. That's what's called a constructor, which just when you make a bubble, when you make an instance of your class, it initializes the values for some of those variables. A class can also have a main method which can be used to test the class. We are very good at writing main methods. It says, let's create a class called person. What would we want to know about a person? What would we want to know depends on what problem we are trying to solve. In one situation, perhaps when creating an address book, we might want to know the person's name and phone number and email. Here's a possible person class with instance variables, a constructor, and methods. So if I want name, email, and phone number, I'm going to say public class person, and then up here I'm going to do my instance variables. Then there's this thing called a constructor that actually allows me to make person objects. And then there are some methods. So what do I want the person class to do? Well, in this case, maybe I want to be able to print out the data about an individual person. It says run the code below to see how it constructs two person objects and fills in their data. We will explain all parts of this class in the next sections, but notice the execution always starts in the main method. When a method like print method is called, we run the code in the print method for that object. After a method is done, the control returns back to the next line of code in the main method. Okay, so down below in Activity 2, Active Code, look at this person class. The instance variables are name, email, and phone number. We're saying every single person has a name. Every single person has an email. Every single person has a phone number. Some of you might be wondering, why is phone number a string instead of an int? Well, maybe you want to have the hyphens in there, something like that. You couldn't do that with an integer. How long is an actual phone number? 3 digits for the area code, 3 digits for... So 7 plus 3, though, for the area code, too. So 10 digits long. 3, 6. I guess you could maybe use an int for that. But here there's a string, so you can put hyphens or parentheses for area code, whatever you want to. That's why the phone number is a string. Then there's this thing called a constructor. We're going to spend a whole day on it eventually, but essentially it says a constructor allows you to create or construct a person, copying in the data into the instance variables, and then here's a method to print out a person. We print out their name, we print out their email, we print out their phone number with a little label before each one. Go ahead, look down below in the main method. There's a couple persons created. There's Sana. Her email address is sana@gmail.com. Her phone number's, that's not a real phone number. I know. And then you got Jean at gmail.com, and here's her phone number, or their phone number. So what's happening here? Well, when I say person P1 equals new person, this is actually going to go back up and look at this constructor that we have up here that says public person, and it's going to send in the data that we sent, which was like Sana, and it's going to, for the email, I think her email was sana@gmail.com, and I think her phone number was like 123456789 or something. It's going to take this data when we said new person and sent this in. It'll send Sana to a init name. It'll send sana@gmail.com to a init email. And it'll take this phone number and store it in a init phone. Then what you do is this data eventually gets stored inside of name, followed by email, followed by phone number. So this would make a person object that has a name of Sana, an email of sana@gmail.com, and a phone number of 123456789 or whatever. That all happens when we say this line of code. When we say new person. What does that really mean for us? Well, every time we create a scanner, when we say something like scanner KB equals new scanner, we're calling a constructor, we're making a new scanner. And so here, we're calling a person constructor, making a new person. When I say p1.print, it should look very similar to when we say kb.next or kb.nextInt or something like that. It says use the object p1 you just created. Here's person p1. p1 is the name of the object I just created. Use the method print on that object. That notation should look really, really familiar because you've done stuff like string1.substring. That says call the substring method on string1. You've done string2.length. That means use the length method on string2, etc. This says call the print method on p1. Well, let's see what the print method does. It prints out their name, email, and phone number, and it knows which object to call the print method on because you're saying p1.print. If I were to go ahead and run this, I got sana@gmail.com, and there's their phone number, Jean@gmail.com, and there's their phone number. Let's go ahead and make another person. Do it with me. So we've made person P1, we made person P2. I think it just logically follows that we make person P3. And I'm just going to follow the code that's like on lines 31 and 28 there. I'll say new person. And if you're wondering what data does it, what order does this data need to be in, you could look at the examples here. And it's pretty clear. It goes name, then email, then phone number. But really, when you say new person, you're calling this constructor up here. And so you could look at that and see that requires name, email, phone number as well. So I'm going to do name, eCalb, Retsoff, email, hello, thank you. Email address, I don't know, ecalb.retsoff@gmail.com. And then you can give this person a phone number. Something like that. Now you can obviously make your own person. You don't have to make the same person as me. And then when I go ahead and run it, I notice that it didn't print out that person. Why not? I don't have a print statement. So even though I made a person, it's not going to do anything until I actually use it. So I would have to do p3.print for this as well. p3.print. And then I might get to see my new person here. Now I get to see eCalb Retsoff, ecalb.retsoff@gmail.com, and their phone number's 911. All right. You guys just made objects for the first time. I'm so proud of you. Well, the second time. We made some bubble objects. I got it right that time. We made some bubble objects on Friday, but you made objects now for the second time with the person class. Actually, the third time. Who am I kidding? Because we made scanners. Actually, the fourth time because strings themselves are objects. So this is almost old hat for you guys, but yeah. I think this is a good time to take our 2-minute break before we go over some more vocabulary. So go ahead and get a drink of water, stretch your... Okay, can't remember my hotkey. All right. So we're going to go over a couple different vocabulary terms here. The first one is instance variables to get a little deeper hold on everything here. It says instance variables hold the data for an object. They record what an object needs to know to do work in the program. So, for example, the bubble class we wrote, it had an X, so it could keep track of where on the screen it was supposed to draw its bubble. It had a Y value, so it could keep track on the screen where it was supposed to draw its bubble. It had a diameter D, so it knew how big to make the bubble. It had a color C, so it knew what color to draw the bubble. Those were all important things, the data that we needed so that the bubble class could do its job. Instance variables are also called attributes, fields, or properties. The other example is the person class we just looked at. A person had a name, an email, a phone number. To write the print method, we needed a name, an email, a phone number. So on our notes here, it says vocabulary. So you might say the data, or I don't know, pick any of these other words that are on here. Data, attributes, fields, properties. I'm going to say properties. I like that one. You could also say fields. You could also say attributes. If you've ever played Pokemon, you're probably thinking every Pokemon has a type. Every Pokemon has a level, a health, a name, stuff like that. Those would be examples of instance variables. They're typically stored using standard variable types like double or int or string. For example, a dog's breed would probably be a string. A car's color would be a string. Somebody's age would be an integer. Somebody's GPA would be a double. So typically that's how those instance variables are stored. Usually they are declared at the top of the class. So I'm going to put that in here. Declared. That's basically how you spell that word. Declared at the top of the class. With the word private in front. Now, this is interesting. We've seen the word public many, many times, but we haven't used the word private that often. We're actually going to start using the word private, and I will explain why very, very shortly. But essentially, instance variables are the data or properties or fields or attributes of a class which are usually stored using standard variable types like double, int, or string. For example, dog's breed, car's color, student's name, student's GPA, a rectangle's width, all that stuff. A bubble's color, X, Y value, whatever. Sometimes these are referred to as an instance variable. Yeah, well, they're called instance variables, no duh. Little redundant there. Okay. And they are declared at the top of the class with the word private in front. If you go back to this person class over here, you see up at the top instance variables, private string name, private string email, private string phone number, etc. If you were to look back at the bubble class from Friday, you'd see private int X, int Y, diameter D, etc. Let's see. Instance variables in general and on the AP CSA exam should be declared private, like we just said. Think of private as like your diary. Only you should have direct access to it. Oh my gosh, how mortified would you be if you walked in and saw your parents reading your diary or something like that? I don't think it's a thing anymore, but when I was your age, we would pass notes. Is that still a thing? No? You guys have cell phones. You just text each other, of course. Okay. We would pass notes to each other and like fold them up. If there was like girl or guy or whatever that you liked, you would like write a note and pass it to them. And then one time I like kept a note and brought it home and put it in my desk drawer. And then later I like went and did something, came back, and my mom was in my room reading the note. I wanted to die. I wanted to die right there. And actually explaining this memory to you right now, I still want to die thinking about it. All right. But no, I'm happy to be alive. Just the memory. Do you guys have any embarrassing memories like that? When you think about it, you're just like, ah! Okay. That's just me. All right. Just me. Cookies and cookie cutters. Okay. In this case, private means that only the code in this class can directly access the instance variable values. So when I went up in this person class and we said private string name, private string email, private string phone number, only the code inside of this person class, only between the curly braces in this person class can the name, email, and phone number be accessed and changed and stuff like that. If somebody else writes their own class, they don't get to see the name, the email, or the phone number. Only inside of this class can I use it. And since they're declared up at the tippy top, you'll notice inside of this constructor, I can just say name, email, and phone number. Why don't I declare them again? Because they've already been declared up above here. I don't need to say string name, string email, string phone number. They're already declared up above. In the print statement, I can just say name, email, or phone number because they're declared up above. And when I say private, only this class can use them like that. It says instance variables are declared right after the class declaration. The thing up at the top when I say public class person, right after it I want to do private string name, whatever. They usually start with private, then the type of the variable, then a name for a variable. Private means only the code in this class has access to it, like we just said. The person class declares 3 private instance variables, name, email, and phone number. These are things that you might want to know about a person. They are declared at the top of the class, and they exist inside the braces of the class. So since they're declared up here, they can be used anywhere inside of the class, as you see here in the constructor method, and you also see here in the print method. They just get used because they're declared as part of the class. They can be used anywhere in the class. Once we have created a class like person, we can have many objects declared of the class. The class is like a blueprint or a cookie cutter, like I said before, that defines the variables and methods for that class. Each object will have their own copies of the same instance variables, but with possibly different values in them. So, just like I said before, one cookie cutter, many possible cookies, one person class, many possible persons, people, etc. Object-oriented programming stresses data encapsulation, where the data, the instance variables, and the code acting on the data, the methods, are wrapped together in a single unit, and the implementation details are hidden. The data is protected from harm by being kept private, like we said before. Anything outside the class can only interact with the public methods, cannot interact directly with the private instance variables. So, as an example, this data in the person class is encapsulated. No other class can access it. Let's think about a bank class. Let's say you're writing a bank account class. What data might you want to have encapsulated so no other class, no other code can modify it or can see it? You probably don't want somebody to see your bank account number, right? So I'd probably encapsulate that. Your balance, maybe you don't want people to see your balance. Stuff like that. If it's a credit card company, you don't want somebody to see the credit card number. You don't want them to see the security code for sure. Stuff like that. Social security number, you would definitely want to encapsulate, make that data private so no bad actors can come in and change that stuff. So data encapsulation, it's kind of confusing. It just means all of the data and all of the methods are in one spot in the class. So I've got it written down on your notes here. At the bottom it says data encapsulation. The data and code acting on the data is wrapped into a single unit. Basically, this is just making instance variables private, so that they can only be accessed in the class, and then also it's the act of putting the methods in the class. Putting the methods, in other words, the verbs, the actions, in the same class. So essentially, if I'm writing a rectangle class, I would want to have private int length, private int width. Wait, what do you guys do? Length and width, right? Private int length, private int width, and then anything else that uses the length and the width. Like, what could I do if I had the length and width of a rectangle? I can find the area. I would put that method, using proper data encapsulation, and put that in the rectangle class. What else could I do with the length and the width? Yeah, I can find the perimeter. I put that method inside of that class. What else could I do? I can find the diagonal, something that's really common this time of year with the Super Bowl when people are buying TVs. It says 55-inch TV. That's the diagonal of the TV. I could find that with the length and the width as well. I would put that in the class. Am I following proper data encapsulation? Okay. Moving on. When designing a class, programmers make decisions about what data to make accessible and or modifiable from some other code, essentially, from an external class. The private, okay, this is getting a little complicated here. Private access modifier is used to, so when we say private, it just means we are encapsulating and protecting the data from external access. Some other programmer can't come in and mess with the name or the email or the phone number, essentially. Private instance variables can only be accessed by methods in the class where they are defined. All right, this question says, click on all the instance variables of the following class. See if you can do it. Keeping in mind that we usually say private before an instance variable, and they're also typically declared at the top of the class. I haven't done this before. I'm assuming I can just click and click. How did I do? Oh, beautiful. The first and last are the instance variables for name. Yes, you can even describe a name using a class. Incredible. All right. Next, methods. Methods define what an object can do or the behavior of the object. It's like the verbs. What can you do? Like a dog can bark, etc. Most methods are public, which means they can be accessed from outside the class. Some other code can use these methods. For example, the square root method. Have you ever seen how the square root method in math.sqrt does its job? I haven't. When I say math.sqrt2, find the square root of 2, do you know the code that finds the square root of 2? I don't know how to do that. Would you know how to physically figure that out? If I say, go, here's a paper and pencil, go figure out the square root of 2, can you do that? No. You don't know how it works, but we can just say math.sqrt because that method has been made public. For example, the substringing stuff in the string class. That stuff is public. We can use those methods even though we don't see how they really work. Some methods can be marked as private, however, if they are helper methods that are just used internally by other methods inside the same class. They will not be accessible outside the class. The private and public keywords determine the external access. Okay, it's just some complicated words here. I'm just going to move on. Basically, methods define what the object can do. They typically start with public, then a type, then the name of the method, followed by parentheses for optional parameters. Methods defined for an object can access and use its instance variables. So, on your notes, it says methods. There's a lot of ways you can talk about methods. You can call it the verbs. You can call it the abilities. It's basically, what can your class do? What can the string class do? You can find the substring, the length, the index of, 2 uppercase, 2 lowercase, etc. Those are methods. Those are the abilities of the class. What could our person class do? Well, really, it could only print. What could a bubble do? A bubble could ascend, and a bubble could be displayed on the screen. Those are all examples of methods, things that you can do. For example, a dog barks, or a car can brake, etc. It says the person class has a constructor called person, which we'll discuss in another lesson, a print method for output, and a main method which runs the whole program. The main method's a little bit different. We'll also discuss accessor methods called getters and mutators called setters or modifiers, which allow to get and set access to the instance variables. So basically, these accessors and mutators that we're going to look at later allow you to change some of the data. What if somebody gets a new last name because they get married or divorced or something like that? Then you probably want to have a method that'll change their name. What if they get a new phone number? So you don't just say, if you say new phone who dis and something like that, you want to be able to update their phone number in there. You might want to have a mutator method that allows you to change the phone number, or they get a new email or something like that. Here is an example of the print method that prints out all the data stored for a person object. Notice that it starts with public, and then the return type. In this case, it's void. The void return type is used to indicate that the method does not return anything. When we say math.sqrt, math.square root, what kind of data does that give us back? Anybody remember? If I say math.sqrt2, what data does it give me back? A double, right? It gives me back like 1 point whatever the square root of 2 is. If I do math.pow, if I say math.pow 2 comma 1.5, 2 to the 1.5 power, it probably gives me back a double. In this case, the return type is void. Void return type is used to indicate that the method does not give back anything. It's like a function. Did you guys ever have function machines back in school where you saw it looked something like this? Number 3 went in, and then out came 6 or something like that. And then you would see 4 goes in, and out comes 8. And you're supposed to figure out what's going on in the box. Did you guys ever do function machines? Something like that? Okay. So in this case, the 3 and the 4, those are what's coming into the function. Those are the inputs or the parameters. The 6 and the 8 are what comes out of the function. Those would be the returns. Just like most mathematical functions have x as an input, f of x would be the output. That's like the return. The void return type is used to indicate that methods does not return anything. Then it has the method name followed by parentheses for possible parameters. I know what time it is. Don't start putting away just yet. The body of the method is in curly braces. Notice that the method can access and use the instance variables. So you can see name and email and phone number in here, which is confusing for some of us because where is name declared? Where is email declared? Where is phone number declared? Somewhere up at the top of the class, but not inside of this method. To call a method to do its job, we create an object of the class and then use the dot operator to call its public methods. For example, p1.print means call p1's print method. So here I create a person object named p1, and then I say p1.print. Last question says, click on all the lines of code that are part of a method in the following class. See if you can do it. And then check yourself. Click on all the lines of code that are part of a method. All right, I think it's any of these lines that start with public and then the braces that are part of it too. Is that right? I hope I'm... Oh no! Methods follow the oh, they're not counting the constructor. Dagnab. Okay. Last thing I want you to write before you go. You saw a person object created right here. This is what's called instantiation. It's just the act of creating an object. So example, circle C equals new circle, salary pay equals new salary, person P1 equals new person, scanner KB equals new scanner, etc., etc., etc. Tomorrow we're going to finish this lesson on classes and objects. I will give you a warning. This is one of the sections that conceptually is very abstract and people that don't struggle can begin to struggle with. If anything was confusing to you today, I would either rewatch the video or go back to this section and look at it, because I don't want things to fall apart now. You have no homework tonight. No homework tonight, so enjoy your Monday evening. Don't lose your note sheet. We are going to finish it tomorrow when I see you.